Hi everyone, for today's lesson we are going to talk about Unit 1, Day 8, Interpreting Graphs Using the Graphing Calculator. Unfortunately, because I cannot guarantee that everybody has access to a graphing calculator, this lesson in its entirety will have to take place a little bit later on in the school year when I can guarantee that everyone will have access to the technology required. Therefore, for this lesson, I would like you guys to please go ahead and skip to the very end where we are going to discuss revenue. So our new learning targets for today are for you to be able to say, I can set up a quadratic function to model revenue in business. I can find the price, quantity, number of price increases or decreases, and the maximum revenue based on this model. So we are going to be focusing on revenue. And revenue means that we are talking about not profit. So that doesn't mean like the amount invested minus the amount that you've received. We are just interested in the amount that you receive. That is considered revenue. It is based on the price per unit. So whatever it is that you are selling, whether you are selling books, or you are selling a service like renting a canoe, for example. All of those things are going to represent a price for your service or a price for whatever it is that you're talking about. And it's going to be multiplied by your quantity. How many books are you selling? How many rentals are you giving out to people? What is going on? So your quantity. So it's price per unit times the quantity or the number of units. Whatever it is that you're talking about in that situation. Whenever we are solving these problems, we always start off by defining our variables. We will have r of x that will represent like the y part of our equation, and we'll have x, just like we normally have in the past. R of x represents our some type of time revenue. So what I mean by that is it might be weekly revenue, daily revenue, monthly revenue, yearly revenue. It'll be some sort of time, and you will see that in the language of the problem. But it represents some sort of time revenue. X always represents the number of price increases or decreases depending on the problem. You will tell if it's an increase or decrease because it will simply say the price increased or the price decreased over time. So let's go ahead and analyze example number 2. Before we get started, I would strongly recommend that you have a calculator with you of some kind. It can be a graphing calculator if you have access. It can be a scientific calculator. It can be a calculator that's on your computer. I have a graphing calculator that I will be working with because that's what I currently have, but you can work with any type of calculator. So for this problem, it says a video store sells about 150 DVDs. Forgive the fact that we are talking about DVDs. Call it something else if it bothers you that much. But this video store sells about 150 DVDs a week at a price of $20 each. So far we've talked about a quantity and a price, and that's what you will see, quantity and price. The owner estimates that for each $1 decrease in price, look at that, X is the number of price decreases, about 25 more DVDs will be sold each week. How can the owner maximize weekly revenue? So please note that whenever you see maximum or maximize, we are always talking about the y part of our vertex. So I'm going to write that down. When you see the language of maximize, or the most that you can make, the maximum revenue, that tells you that we are always going to look for the y part of the vertex. because the y part of the vertex is going to represent your max value. And if it's a max value, you can pretty much anticipate that any parabola that we will have will be pointing down. So there will be a max value that we will have. All right, let's go ahead and look at this problem once again, and let's define our variables. It says a video store sells 150 DVDs a week at a price of $20 each. The owner estimates that for each $1 decrease in price, about 25 more DVDs will be sold each week. How can the owner maximize the weekly revenue? So the first thing that we always do is define our variables. So that is always what we do first. And so for room purposes, I'm going to define my variables up here. And I'm going to say that X is going to equal, remember, it's the number of price increases or decreases. And it's going to be the number of $1 decreases in price. So it's going to be the number of decreases that we have. So if this was like $5, for example, we would still say the number of price decreases. Where R of X, our time that we're working with, is week per week, weekly revenue. Okay, cool. So now that we've defined our variables, the next thing we need to do is write our equation. And I'm going to write this as R of X equals. And there are two pieces that we're going to be talking about. Now I'm going to put into parentheses price per unit and quantity. And the reason why I'm doing this is because I want to show you that the way that we are going to be setting up these problems is very similar to a different structure that we've already learned. And that structure is intercept form. Intercept form, remember, has two parentheses where we had information inside of one parenthesis and information inside of the other, and we were able to identify our x-intercepts. That is the same exact structure that we are going to be working with here. So let's go ahead and talk about price. The price starts off being $20 for each DVD. And then the price is decreased by $1 every single time. So I always start off with whatever we start off with. In this case, it's $20. Then I have a $1 decrease in price. Decrease means minus. And if this was a 5, I would write 5x. In this case, because it is $1, I'm just going to write x. Remember, x represents the number of decreases. So if x was 1, the price would decrease by $1. If this was 2, it would decrease by $2, if that makes sense. Next, we're going to talk about quantity. We start off with 150 DVDs that we are selling each week. And for every time that the price decreases, 25 more DVDs are sold each week. Think about it. If the price goes down, wouldn't more people want to buy it because it's cheaper? Makes sense. So that means that the number of DVDs, or the quantity, is going to increase by $25, or by 25 for each price decrease. And that is my equation. One is dealing with price and the other is dealing with quantity. And I would always recommend writing down what you start with first and then what is happening with X second. And then that way you're keeping yourself normal. Okay, so our goal is to figure out how can the owner maximize his weekly revenue. So because this is in intercept form, one of the things that we can do is we can use that formula of x is equal to p plus q divided by 2 to identify what our vertex x is. If we know what our vertex x is, then we can substitute that value in to help us to find our vertex y. Because our vertex, if you remember, is p plus q, divided by 2, comma, some y value. And once we know what that y value is, that's going to represent our revenue. So how do we find our p's and q's? Now remember, p's and q's represent our x-intercepts. X-intercepts happen when we have p comma 0 and q comma 0. In math, x-intercepts are also called the zeros of a function. And that's because that's where the function crosses the x-axis. So if I were to plot or give a quick graph of what the x-intercepts represent, they're called zeros because that is where the function of y is equal to 0. As we get further along into this unit, we will explore these vocab words a little bit more, but I need you to know that an x-intercept is a 0, and so the way to find p and q, we are going to set each parenthesis equal to 0 to help us find our p and q. So I'm going to set 20 minus x equal to 0. This will help me to find my first y-intercept. I'm going to add x to both sides. And when I do that, I find that 20 is equal to x. So my first x-intercept is 20, 0. My next x-intercept is where I'm going to set 150 plus 25x equal to 0. I'm going to subtract 150 on both sides. And when I do that, I end up with 25x is equal to negative 150. Dividing both sides by 25, we find that x is equal to, well, negative 150 divided by 25. That is equal to negative 6. Cool. So my p is 20 and my q is negative 6. So now I can find my vertex x, which is p plus q divided by 2. So that's going to be 20 plus negative 6 divided by 2. This is equal to 14 divided by 2, which is 7. Okay, so what does this mean? The 7 really quick. Okay, if x is equal to 7, that means that we should probably decrease the price by $7 or decrease it 7 times. So that's what that means. And I'm going to write my vertex as 7, something. And I'm going to write down what this means is that the owner should reduce the price by $7. What would that price be? Well, that price would be 20 minus x, because remember this first parenthesis represented our price. So that price is going to be 20 minus 7, which is $13. They should sell $13 per DVD in order to make that maximum profit. Okay, let's go ahead and continue to find what that maximum profit is. Because I know that x is equal to 7, I'm going to substitute 7 into my function. So I'm going to write r of 7 is equal to, parentheses, 20 minus 7 times 150 plus 25 times 7. If you want, you can simplify each parenthesis individually. So r of 7 is going to be equal to 20 minus 7, which is that 13. That 13 means that we should probably charge $13 per DVD to make that maximum revenue. Let's go ahead and find out how many DVDs this person is going to sell. So I'm going to put into my calculator 150 plus 25 times 7. And when I do that, I end up with 325. So what 325 means is that the owner should probably sell, if they sell their DVDs for $13 a piece, they're going to sell total of 325 DVDs. And 13 times 325 is 4,225. So the owner should reduce the price by $7, and that would give a maximum profit, or not profit, a maximum weekly revenue of $4,225. And so that was a lot of information that we were able to find just based on our function. if you do have a graphing calculator, I would recommend just just watching what I'm doing and maybe practicing this. If you don't have a graphing calculator, just watch. I'm going to put in 20 minus x into one parentheses, and I'm going to put in 150 plus 25x into my other parentheses. This is under y equals, and I'm just entering in my equation that I was able to come up with. From here, I'm going to go down to zoom, and I'm going to go to zoom fit. So zoom 0 for me. And when I press enter, it gives me this very lovely parabola. And I'm probably going to adjust it so that I can see it just a little bit clearer. I know that I had my x-intercepts on each side, so I probably would want to make my window just a little bit bigger. So I'm going to go to window, and I don't mind it going from -10, but my other 0 that I had was 20, so I'm going to make this 25. And then from here, I'm going to make my y maximum, instead of 4,224.97, I'm going to make it 4,400 for my y maximum. My y minimum being -3,000 is perfectly fine. And I'll go by a scale of maybe 500s. Let's see what that looks like. Awesome. So there's our parabola. And what we would want to do is we would press second trace, and we would want to identify what that maximum value is. And so we would have, we would look at the left bound, we look at the right bound. Our goal is to try to get this y value to be as big as possible. So it looks like I can get it all the way up to 4,224 at 0.97. So I think that's the highest that I'm able to get it at. And I'm going to call that my left bound. Enter. And I really don't think I can make it, maybe make it 1 to the right. Enter, enter. And look at that. Our maximum is at a 7 and 4,225. And this is where the graphing calculator is really helpful because it tells you that answer right away. But you don't need to do that because the algebra will allow you to do that for you. So our vertex is going to be 7, 4,225. And so in context, you should reduce the price 7 times in order for you to reach a weekly maximum revenue of 4,225. You should sell those DVDs for $13 a piece because you will sell a maximum of 325, you will sell a total of 325 DVDs. And together, when they're multiplied together, you will end up with 4,225 is your weekly revenue, maximum weekly revenue. All right, so when it comes to this you try, let's go ahead and analyze this. It says you run a canoe rental business on a small river in Ohio. You currently charge $12 per canoe and an average 36 rentals a day. An industry journal says that for every 50-cent increase in rental price, the average business can expect to lose 2 rentals a day. Use this information to attempt to maximize your income. What should you charge? Okay, so when you see that word maximum, that is your clue that we want to look at our vertex. And the question that we really want to answer is, what should you charge? Okay, so let's go ahead and define some variables. I am going to let x equal the number of price increases this time. And r of x this time around looks like we're talking about per day. So this is going to be daily revenue. Okay, now let's go ahead and write our equation, starting with price. So it looks like we start off by charging people $12, and the price is going to be for every 50-cent increase. So it's going to increase by 50 cents. So I'm going to write 0.5x each time, times, I start off with 36 rentals a day. But because I'm increasing the price, I'm going to lose, which means minus 2 rentals a day, 2x. From here, we want to look at least finding the x part of the vertex, because that x value is going to help me to find what my price should be. And remember, that first parenthesis is your price. So the way we find the x part of our vertex is to find our p's and q's. To find our p's and q's, or our x-intercepts, we're going to set each parenthesis equal to 0. So I'm going to write 12 plus 0.5x equals 0. I'm going to subtract 12 on both sides, so I end up with 0.5x is equal to negative 12. And I'm going to divide both sides by 0.5. And if you have a calculator, I would recommend that you just put in negative 12 divided by 0.5. And when you do that, you end up with negative 24. So negative 24 is going to be an x-intercept. Next, we're going to set 36 minus 2x equal to 0. I'm going to add 2x to the other side, so this becomes 36 is equal to 2x. And I'm going to divide both sides by 2. And when I divide both sides by 2, I end up with x is equal to 18. All right, so here are my x-intercepts, and now I want to find x equals. This is my vertex x, so if this helps you to write the vertex x, so Vx, vertex x, that's going to be the average of your x-intercepts. So that's negative 24 plus 18 divided by 2. So negative 24 plus 18 is negative 6. Divided by 2, that is negative 3. So the x part of my vertex is negative 3. Hold on. This is really weird. But x is supposed to be the number of price increases, and yet I find that x is equal to negative 3. So what that actually tells me is that increasing the price is not going to provide me with my maximum value. Instead, I should probably decrease the price 3 times. So let's go back and look at what our price should actually be. So remember that the price parenthesis was the 12 plus 0.5x. So let's figure out what our price should be. That's 12 plus 0.05 times negative 3. And when you put that into your calculator, 12 plus 0.5 times negative 3, you're going to end up with 10.5. So what does that mean? Well, that means that this person should charge, instead of increasing the price, they should charge $10.50 in order for them to make a maximum profit. That's how much they should charge. Not profit, excuse me, for a maximum revenue. And instead of increasing the price by 50 cents, they should actually decrease it 3 times, so decrease it by $1.50. That's what should actually happen. Now let's go ahead and for fun, I'm just going to skip this part right here. For fun, let's go ahead and find out what that maximum revenue would be. So far, I know that my vertex x is negative 3, and let's go ahead and find what the y part of that vertex would be. So the y part is where I'm going to go r of negative 3 is equal to, and I'm just going to substitute negative 3 into the parentheses up here. So that's going to be 12 plus 0.5 times negative 3 times 36 minus 2 times negative 3. I already know that this first parenthesis is 10.5, and I'm going to put 36 minus 2 times negative 3. When I put that value into my calculator, I end up with 42. What does this 42 mean? Well, we know what 10.5 means. 10.5 means that they should probably charge $10.50. That's what we figured out in the last problem. What does 42 mean? Well, 42, that means that they will have 42 rentals per day. So there will be a lot more rentals. And by doing that, they will get a maximum revenue of 42 times 10.5 is $441. So that is my maximum revenue. So the maximum revenue maximum daily revenue is $441. And that will happen if you decrease the price instead of increasing the price. Decrease the price 3 times, which would mean that you would need to decrease the price by about $1.50. And that's what you would end up having. We can also graph this one in our graphing calculator just to verify that we did it correctly. So we would put in 12 plus 0.5x and 36 minus 2x. I'm going to press zoom 0 just so that I can see what this graph would look like. And we can clearly see that it reaches like a maximum, comes back down. I would probably work with my intercepts, which are negative 24 to 18, and adjust my window by going from negative, maybe make it negative 30. 25 is perfectly fine. Scale of 1 is perfectly fine. And then my minimum being negative 343 is perfectly fine, but I'm going to make my maximum instead of 440.98. I'm going to make it maybe 450 and make my scale go by, let's just make it 50s this time. This is just, coming up with using my information to my advantage in terms of creating a reasonable graph. So voila, there's our very lovely parabola, and I can press second trace and go down to maximum to identify what that max value is. So my goal is to try to make this y value as big as I possibly can. And it looks like the biggest that I can make it is that 440.99. So I'm going to go just to the left of that, and I'm going to press enter, which is 440.88. Enter, and I'm going to press the right arrow one time because I'm going to call that my right bound. And I'm going to press enter, and they're going to say, is that your guess? I'm going to say, yeah, enter. And there you go, negative 3 and 441. So that just confirms and checks what my answer actually is. That is the end of today's lesson. If you have any questions pertaining to revenue, please feel free to email me. Otherwise, I hope you have an awesome day.